Assalamualaikum. Key topic for our group is the principle of linear impulse and momentum. First of all, let me introduce our group members. First, Afifah Ayuni binti Yazid. Second, Khadijah binti Uthman. Third, Siti Alia Kristina binti Syekh Ahmadi. And I, Nurhidayah Najwa binti Azlam. So next is introduction. What is pulse? Is a particle in most dynamic issues are subject to force that change with time. The force is a vector value function of time which we may express analytically. In classic mechanics, the integral of a force F over the time interval t, the S is called impulse. In the same way that force is a vector quantity, when an object experiences an impulse, it experiences a vector change in its linear momentum in the opposite direction. That is, what is momentum? The product of a particle's mass and velocity is called momentum. The term momentum refers to a quantity that has both a magnitude and a direction. The temporal rate of change in momentum is equal to the force applied on the particle. According to Isaac Newton's second rule of motion, P is equal to mv, where P is a momentum, m is a mass, and v is a velocity.
I'm going to continue with basic theory. As the principle of linear impulse, the momentum when considering ways to lower forces during collisions, we instinctively know that extending the collision period is beneficial. So the impulse is defined as the product of force and collision time. So the impulse momentum theorem asserts that change in momentum of an item is equal to the impulse supplied to it. So we use three kinds of equation. Number one is mv1 plus integration of t1 until t2 f dt is equals to mv2. Number two, we use ns equals to kg meter per second. So the impulse momentum theorem is logically equivalent to Newton's second law of motion. So next is F equals to m multiplied by Vf minus Vi, which is that we notice that we have to calculate a change in momentum as the initial momentum subtracted from the final momentum. If the mass of the object doesn't change during the collision, then the initial and final mass are the same. So this integral is clearly only the first integral of the equation of motion. This equation differs from the work energy equation in that it is a vector equation, which means that forces operating in one coordinate direction only modify the linear momentum in that direction.
Next is basic theory. The principle of impulse and momentum define how applied forces and moment affect an object linear and angular momentum is known as the linear impulse and momentum principle. It may be used to particle motion as well as rigid body motion. In mechanics, the word energy concept is an extremely helpful instrument. By integrating Newton's second law with regard to time, we may obtain another valuable tool for motion analysis. Newton's second law is written in the following way, where V1 and V2 are the velocity of the center of mass of the object at the time t1 and t2. The term on the left is called the linear impulse and mv is the linear momentum. Equation above is called the principle of impulse and momentum. The impulse applied to an object during an interval of time is equal to the change in the object linear momentum. The dimension of the linear impulse and linear momentum are mass multiplied length over time.
So next, I'm going to continue with case study 1. So for the question, the man kicks a 0.5 kilogram football over a goal, goes from 73 meters away, causing it to reach the crossbar 6 meters above the ground. Calculate the average impulse force between the foot and the ball if the time the lumen's foot is in contact with the ball is 0.3 seconds. So in the question given, angle for the ball and lumen's foot from the ground is 45 degrees. Solve the question that I've read before. We use this equation, which is u is equals to v squared y divided by 2 gravity, which is 9.81. So as we know here, initial speed for the question is 0, so we need to replace it with the height equation. So height is equals to 6 meters times 2 times 9.81, so we will get 117.72. So the values for v squared y is equal 117.72. But here, we only need the vy value, so we need to square it. So vy we will get 10.85 meters per second. But now, we need the final value for the ball from the air to the ground, which is v. So we use this equation, which is Vy is equals to V sine alpha. So Vy is 10.85 equals to V sine 45. So we will get V is equals equals to 15.34 meter per second. So now we want to know the average impulse force. So we use this equation, which is F is equals to mv divided by t. So m is 0.5 as given in the question, 15.34 as we calculate just now, and divided by the time is 0.3. So when we get the force for the average impulse is 25.57 Newton. So that's all for the average impulse force.
Hi, my name is Afifa and I'll be continuing with the second case study. The question is, when a 190-gram cricket ball is served, it is impacted by the bowler when the ball is at the maximum height of the toes. If the speed of the ball before the impact serve is 245 km per hour and after the impact the speed increased to 75 meter per second, determine the average impulsive force acting on the ball if the cricket ball experience the change in speed in only 0.13 seconds. Okay, before we continue with the solution, first we need to list all of the unknown that we know from the question. So for this question, the unknown that we know is m. M is the mass. The mass is 160 gram. In the standard units of calculation, we need to use kilogram for the mass. So 160 gram must multiply by 10 to the power of -3. So we get 0.16 kilogram. Next is V1. V1 we know from the question, V1 is equal to 245 km per hour. So in standard unit, we must use meter per second. Then 245 we must multiply by 100, 1000 divided by 3600. So we get 98.09 meter per second. Next is V2, which is 75 meter per second, and last we know is T2 is equal to 0.13 second. Okay, let's continue with the solution. To find the average impulsive force acting on the ball, we need to use the formula mv1 plus sum of integration t1 t2 fdt is equal to mv2. From the unknown that we know, we just substitute it to this formula. And for the integration of t1 t2 fdt, we just say it as a f to the bracket of 0.13 minus 0. Then we calculate it, so we get f is equal to 8.54 Newton. So that is the answer for the average impulsive force acting on the ball. Okay, next for the case study 3, the question is the two weight in figure beside are released from a rest. If sum of integration T1 T2 FTT is 320 minus 40, use the principle of impulse and momentum to determine the velocity of the weight after 0.59 seconds. Okay, as I said before this, before we continue with the solution, we need to list all of the unknown that we know from the question. So the unknown that we know is M1 is equal to 10 kg, M2 is 5 kg, V1 is 0 because as stated in the question, the weight is released on a rest, so it is equal to 0. V2 is the one that we need to find, and the T is 0.59 seconds. Okay, let's continue with the solution. For this question, we use the same formula as before, but I change it to sum of integration T1 T2 FDT is equal to M2 V2 minus M1 V1. And then we substitute all the unknown that we know into this equation. Then for the integration, it will become 320 T minus 40 to the power of 2 divided by 2. So we change the T is equal to 0.59. Then we get V2 is equal to 18.81 meter per second.
So, for the fourth case study the question is a racket hits a 40-gram tennis ball over a 3-time interval. The ball travels at a speed of 35 and at a 40-degree angle. Neglect the weight of the ball as it is struck. Find the average impulsive force exerted on the ball and the momentum of the ball 1 second after it leaves the racket surface. Okay, for the solution, firstly, we list all the information given in the question. Mass of the tennis ball is 0.004 kg. The speed of the ball before the impact is 0. The increased speed after the impact, 35. The degree is 40. The time before is 0 second. The time after is 3 seconds. And after that, their magnitudes are so minor in the comparison to the racket's impulse. The impulse induced by the ball's weight and the normal force N can be ignored. The racket's impulse must be in direction of the final velocity, that is v2, because the initial velocity, that is v1, is 0. Then, to get the final answer, the f, we insert all of the information given into the formula, and then we get the f. Okay, we substitute all of the information given to the formula mv1 plus sum of integrate t2 and t1, f dt equals to mv2, and then the f we will get 467 Newton. And then substitute all of the information in the second formula. It is v2x equal v1x equal v1 cos 40 degree equal 35 cos 40 degree equal to 26.81, and we will get v2 is 81i plus 12.69j. And lastly, substitute all of the information in the formula L2 equal mv2 equal 0.04 and multiply it to 26.81i plus 12.69j, and then we will get L2 equal to 1.18. So, for the fifth and last case study, the question is, given that two lorries of MA 35 mg and MB 15 mg and the velocities are given in the picture, find the average impulse force between the lorries if the coupling takes place in 0.8 seconds, and find the speed of the lorries after they meet. Okay, right now for the solution, as usual, we must list all of the information given. Firstly, MA 35,000 kilogram, MB is 15,000 kilogram, and for the VA is 1 and VB is 1.5. To find the velocity of the two lorries after meet, use the conversion of linear momentum formula. Insert all of the information that given in the question and the picture, then find the velocity. After that, find the impulsive force by looking at only one lorry using the principle of impulse and momentum formula. Insert all of the information, and at the final answer, we'll get the impulsive force. Okay, substitute all of the information in the formula. MAVA1 plus MBVB1 equal to MA plus MB multiplied with V2, and V2 we will get 0.25, and use the V2 in the second formula, that is where we want to find the F average, and we will get 32,812.5 Newton.
As a conclusion, all of us know what the principle of linear impulse and momentum in deep spinning. The principle of impulse and momentum define how to apply forces and moment affect an object linear and angular momentum. Linear impulse is a particle in most dynamic issues are subject to forces that change with time. The force is a vector value function of time, which we may express analytically. Momentum is the product of a particle mass and velocity. Other than that, we all know how to use the formula in a correct way to find the linear impulse and momentum. At first, we also